I welcome you all to this wonderful lesson. So, this is a lesson that I want us to discuss. This is School at 5. So, for those of you that have joined in, this is School at 5 where we get to devise through exam questions, topics that gets to come in an exam in mathematics, chemistry, and physics. So, today we are talking about mass and weight. So, this is physics. These are questions that get to come in an exam. You are going to see one or two questions in an exam that will come under this important topic. So I think we've all joined in even as we start looking at this wonderful topic. So even as we start, I pray that you understand everything that I'm going to share in this wonderful lesson, and that God should help you remember or put everything we're going to discuss here into remembrance even as you enter in the exam room. So my prayer is to help you get a distinction, and we are trying by all means as an academy to help people get distinctions. So now, this is what we want to start with. This is what I want you to understand. So by the end of the lesson, you must be able to answer questions that get to come in an exam under mass and weight. So before I go any further, there are what we call 7 fundamental SI units. So among 7 fundamental SI units, there are what we call 7 fundamental SI units. So we've got 7 fundamental SI units, or rather we've got 7 fundamental physical quantities. So when we are talking about a physical quantity, is something that can be measured. So a physical quantity is anything that can be measured. And we've got 7 fundamental physical quantities that you are supposed to know and understand. So amongst which we've got the basic. So I'm saying that we've got the basic. These basic are also called what? Base. Apart from knowing the basic, we also have what we call the derived. So we also have the derived physical quantities. So now, amongst the basic quantities, there is what we call mass. Mass is a physical quantity which is basic. So mass is a basic physical quantity. But whenever we are talking about a derived, we are talking about weight is a good example. Weight is a good example of a derived. So mass being the basic physical quantity, meaning it only has one SI unit. So all the basic quantities are formed and they only have one SI unit. We don't need to combine a lot of units to come up with a basic or base physical quantities. No. But for the derived ones are formed by combining basic physical quantities like weight. Weight is an example of a derived quantity. So this is what you need to know. I remember I discussed through this. You need to know and understand all the 7 basic physical quantities. So this is just something that I wanted us to start with, even as we go into our topic here. So you now understand that this is a basic physical quantity. This is a derived. This one is formed by combining basic units, but this one is just one. So this one has more than one SI unit involved in it. So let us start with mass. This is what we are starting with. We start with mass. We see how we get to understand what mass is. So whenever we are talking about mass, what you need to know is that mass is the quantity. So whenever we are talking about mass, we are just talking about the quantity. So this is the quantity of matter. The quantity of matter contained. So this is just the quantity of matter contained in a substance. Contained in a substance. So the quantity of matter contained in a substance is what we are calling mass. So each time that you get to talk of mass, we are just talking about the quantity of matter that is contained in a substance. I believe you are able to see what is happening. People have connected. So even as we've connected, I want you to share this video. So I'm saying that the quantity of matter contained in a substance is what I'm calling what? Mass. So if a question was to come that what is mass, you are going to tell them that mass is the quantity of matter that is contained in a substance. So you discover that mass is the same everywhere. Mass is the same. Mass is the what? Mass is the same everywhere. Everywhere. Wherever you go, mass is the same. So anywhere that you are going to go, mass is the same. The mass of an object, the mass of a substance is the same. Even your mass is the same. Wherever you go, the mass is the same. So this is what you need to understand. You go to the moon, you go to the what? Mass is the same. So this is what you need to know and understand. Mass is the what? Mass is the same. Mass doesn't change. Mass will never change. Mass is just the same. Same applies with you. Your mass can never decrease. Your mass will just keep on rising. Your mass as a person, your mass will just keep on rising. You can't say that today your mass is 20 kg, tomorrow your mass is 15 kg. No. The mass will keep on rising. Mass will not change. Mass is just, if it is the mass of an object, that object will just have the same mass wherever it goes. So this is what you need to know. This is what you need to understand. Now, we now look at an instrument that is used to measure mass. What instrument do we use to measure mass? So the instrument that is used for mass is what? Is what we call a beam balance. We call it what? We call it a beam balance. Oh, since the world has now advanced, we can use also what we call an electronic balance. So these are two instruments that are used to measure the mass of an object. Whenever we are talking about a beam balance, I think we know this. A beam balance is that thing that is used to measure the mass of an object, even without using power, electricity. This one doesn't use electricity, doesn't require electricity for it to operate. But whenever you are talking about an electronic balance, there is need for this to work. You need to connect to a circuit. That's when this one will work. So if you've tried to check properly in our labs, we get to have beam balances, even electronic balances. So this is the instrument that is used to measure what? To measure weight, to measure the mass of an object. So now, apart from knowing the instrument that is used, you know that SI unit. What is the SI unit? SI unit for mass. So the SI unit for mass is, SI unit is what? Kilogram. So this is kilogram. The symbol is what? kg. Any question that you are going to calculate in physics, you need to know that mass should be put in what? Kilograms. So you need to make sure that the mass of an object is always in what? Kilograms. We will always put in kgs. So this is what you need to know and understand. Away from this now, this is all that you need to know on the mass. We also go to the weight. You need to know what weight is. So by definition, what you are going to do, or what you need to understand for you to know what weight is, you know that weight is just the attractive force that is exerted on an object due to pull of gravity, or due to gravity. So that attractive force that is exerted on an object due to gravity is what we are calling weight. In other words, weight is just a pull of gravity on an object. So you can say that this is just an attractive. So this is just an attractive. So an attractive force. So an attractive force exerted. So an attractive force exerted on an object. On an object due to gravity. So you can put this definition. Oh, this is just the same as the pull of gravity on an object. This is why gravity, this is the reason why weight gets to vary. So this is the reason why weight varies from press to press. From where? From press to press. Weight is going to change. Weight is never the same. When you go to the moon, there is a specific weight that is there. When you are on the earth, you get to have a weight. So you discover now that weight is just the attractive force exerted on an object due to the gravity. So this one, there is what? Gravity involved. This is the reason why you can even observe this by yourself. When you go to certain places, you discover that you will either gain or lose weight. So, because weight is affected by the pull of gravity. So, this is just an attractive force that is exerted on an object. This is what you need to understand. So, I think you are able to agree with me that when you are in Lusaka, you get to have a certain weight compared to when you go to Ndora, when you go to Livingstone, you get to have a different weight. Or maybe you are here in Cabo where I am. Your weight is affected. So discover that your weight is affected due to gravity. There is gravity that is involved. It is the pull of gravity on an object. So weight gets to change. That's why weight is never the same. Weight will vary from press to press. So this is what you need to understand. It will vary from press to press. So we also have an instrument that is used to measure weight. So an instrument used to measure weight. What do we call an instrument used to measure weight? It is called what? A spring balance. We get to call it a spring balance. I think people are able to see what I'm writing here. You are able to get and understand. So these are some of the things that you need to know. These are some of the things that you need to understand as a student. So make sure that you know this. Make sure that you understand everything that I'm sharing with you here. These are the basics. These are the foundation. So a spring balance is an instrument used whenever we want to measure weight. Have you seen? So this is what you need to know. This is what you need to understand. So let us now progress. So even as we progress, if you are watching this, make sure that you share this video. Let's make sure that we share. Let's make sure that we share this video. Let's share. Let's share. Let's share. Let's share. Let's make sure that we share this video. We share. Let's share. This is the best thing that you can ever do to me. When I'm live, when I've posted the video, if you can just share. I get to see the people that gets to share, gets to see notifications of people that gets to share. Say, okay, these people are supportive. So the other thing that I forgot here, the SI unit. The SI unit is Newton. So the SI unit for weight is Newton. Now, let us now talk about the relationship that is there. So the relationship that is there, the relationship between, so we look at the relationship that is there between mass and weight. The relationship that gets to exist. So the relationship that gets to be there, you discover that weight of an object, is directly, this is what you need to understand. It is what? Directly proportional. It is directly proportional to mass. This is the relationship that gets to exist. So the relationship that is there between mass and weight is that the weight of an object is directly proportional to the mass. You discover that when you want to find weight, you're going to say weight is equal to mass times what? Gravity. So these two are direct. Have you seen? Direct. When it is inverse proportional, we get to mean that it is like this. So when I say that the acceleration is inversely proportional to the mass, have you seen? So acceleration is inversely proportional to the mass. This is what is there, inversely, so it is down there over. But in this case, I'm saying that weight of an object is directly proportional. They are in a straight line like this. But the relationship that is there between acceleration and mass is that acceleration is inversely proportional to the mass of an object. Hope you are able to see the relationship that is there. So even as we look at Newton motions, first law, second law, when we start looking at those, that's when you are going to understand this. What I get to mean when you start looking at forces. But we are looking at the weight and mass. This is the relationship that is there. These two are directly proportional. So it is directly proportional to mass. Weight is directly proportional to mass. So this is what you need to know. This is what you need to understand. So now, the relationship that is there, let me do this. So what you need to understand is that when you go to the moon, when you are, so there are three places here. There is what we call the earth. We also have the moon. We also have the outer space. Outer what? Outer space. So these are three places where we can calculate. So I'm going to say this is so I'm going to say this is I'm going to say Earth. So Earth here, I'm going to say let me do this. Let me do this so that okay, I'm going to do this. This is what I'm going to do. So I'm going to say this is mass and this is weight. I want to make a table that will really help us. So what we need to know and understand is that like this. So I'm going to do this. Three places that you need to understand. So three places that you need to get and understand. So I'll start with the Earth. This is Earth. This is the middle one is the moon. Then this one is the outer space. So the last one is the outer space. Hope you're able to see that simple table that I've written there. So these are just some of the things that you are supposed to know. So on the earth, you discover that whenever we are talking about gravity, on the earth, gravity is equal to what? 10 meter per second squared. This is the gravity on the earth. But when you go to the moon, the gravity on the moon is 1 over what? 6 times the gravity on the earth. So it is 1 over 6. So this one would discover that it is giving us now 1.6 somewhere there. So 1.67 somewhere there. This is what you need to know and understand. So it is giving us, let me say 1.67 meter per like that. So this one, this is the what? The gravity of an object on Earth. The gravity is 10. Just understand this. The gravity is 10. But when you go to the moon, the gravity is approximated to be like that. When you go to the outer space, when you move to the outer space, on the outer space, there is no what? There is no gravity. That's why weight is 0, because there is no gravity. So this is what you need to know and understand. There we don't have any gravity. So let's share this. Let's make sure that we share this video. I want people to share. I want you to share so that we get to reach a larger audience. So let's make sure that we share this video. We get to understand everything that I'm going to be sharing here. I want you people to share. Let's make sure that we share. Let's keep on sharing. Let's keep on sharing. Let's keep on sharing. So make sure that you share this wonderful video. Make sure you share this wonderful video that is here. Make sure that you share, you share. Let's make sure that we share, we share. I want you people to share this. I want you to understand this very well. I want you to share. I want you to share. So you can share in as many groups as possible. So now, what we now need to know and understand is this. This is what you need to understand. So we are talking about 3 places here. This is the earth. The middle one is the moon. Then the other one is the outer space. So whenever we've got mass, I'm going to say if mass is here, so here I'm going to put kgs. So I'm going to say this is kgs. So if the mass is 60, what is the weight on the earth? So weight on the earth, you know that the formula you are going to use is this one. Weight is equal to mass times what? Gravity. So meaning that you are going to say that gravity on the earth is 10. So mass 60 times 10, what are you having? 600. So it is what? 600. This is what you are going to get. So this is 600 newtons. So let me do this. I indicate here. So these are newtons. Weight is in Newton. So these are newtons like this. So I do this. This is what I'm going to do. So it is 600. When I go to the moon, mass is still the same. This is my mass. Mass will still be what? 60 kg. Even when I go to the moon, mass will still be 60. So now, but how about the weight? I know that weight is equal to mass times what? Gravity. So what I have is that when I calculate here, so I know there are people that are having calculators. I want you to calculate this. When you multiply, mass is 60 like this. When you say times 10 times 1/6, this is what I told you, that the mass of the gravity on the moon is 1/6 of the what? Gravity that is on the earth. So you can do this if you want. But if you want, you can just go direct where you say 6 times 1.6. You can multiply. So let us multiply. We see the answer that we are getting. So someone to multiply this, and someone, you can put a 7 there, because you know that it is 10/6. This into that, it is 1. Remainder 4. 6 into 4. What are we getting? It's I'll put a 0 there. 60. That's 46. We're going to 6.6. So someone to multiply this. What answer are you getting? This or even that? So I want to see comments. What answer are we getting? What is the weight there? What are we supposed to do? What are we supposed to do? So I can see a question here. Someone saying, can you repeat? Where exactly should I repeat? So where exactly should I repeat? Because here I've just put this table here. So the table, let me try to make it big so that it is visible. Let me try to make it big so that it is visible like this. This is the table that I've put here. So I'm talking about 2 things here. So this is a table. The table is like this. This is a table. So there is mass. We are also talking about weight. So like this, something like this. So earth, on the earth, on the moon, and outer space. So we want to find the mass. So mass, want to find the mass, which is in kg. Here, want to find the weight, which is in what? In newtons. So, according to what we've said, we are using mass as 60. So, if mass is 60, what is the weight there? The weight, where are we on the earth? What is gravity on the earth? 60. So, you know that weight is equal to mass times gravity. So, you just multiply mass 60 times 10 to give you what? 600 there. Mass is 60 even when you go to the moon. But I'm telling you that when we multiply there now, we know that to the moon, the gravity is what? So mass is equal to, weight is equal to mass times gravity. So you know that gravity, weight is equal to mass 600 times gravity, which is 1.67. That is gravity on the moon. So what answer are we getting? How did you find 1.67? So I've said that this is what I'm saying. I'm saying that the way we get to find gravity. So this is gravity. So these numbers, you are supposed to know them. You are just supposed to understand them. So gravity on the earth. So 3 places. Gravity on the earth is approximated to be, it is 9.8. But instead of dealing with decimal numbers or points, it's better we just convert to all numbers. That's why on the earth, gravity is 10 meter per second squared. This is what you need to know. So that is what gravity on the earth. That is gravity on the earth. So the gravity that is on the earth is this one. We get to use 10. So even when we are talking about certain questions that get to come in an exam, when gravity, we know that gravity we use 10. This is the gravity that is approximated on the earth. When you go to the moon, gravity is said to be 10 times 1 over 6. So gravity is 1 over 6 that of gravity on the earth. So when you multiply here, you are going to get 1.67 meter per second squared. So this is the gravity on the moon. So gravity on the moon is given by this. This is gravity on the moon. So it is approximated to be 1 over 6 times that of the earth gravity. So this is what I mean. This is the gravity that we get to talk about when you go to the moon. That is gravity that we get to use. Then there is also the outer space. So in the outer space, there is no gravity. So this is what you need to understand. In the outer space, there is no gravity. These are some of the things that you are supposed to know. These are some of the things that you need to understand. So I can see answers here. I can see answers here. So 60 by, so I want you to multiply this. So we are multiplying 60. So this is what we are. Hope we've understood. Gravity on the space, I've said there's no gravity there. Gravity is equal to 0 meter per second squared. This is gravity. There's no gravity on the outer space. But here, have you seen mass is the same everywhere? I've told you that mass is the same everywhere. So when we multiply, want to find on the moon this side. So here we know that definitely it is a 0. There's no gravity there. This is what you need to understand. So these are some of the things that you need to know. These are some of the things that you need to get. So let's make sure that we understand this. Let's make sure that we know how to answer questions in an exam that gets to come in that way. So these are few things that you need to know. These are few things that you need to take note of. So let us multiply. We can multiply. Let us multiply. What answer are we getting? 60 times 1.67. What is the answer there? So what answer are we getting? Let me see the answer there. What answer are we getting? What is the answer there when we multiply? What answer are we getting? What answer are we going to get? Okay, someone to comment the answer. Just multiply there. So just multiply there. Let's just multiply there. 60 times 1.67. This is the moon. We are on the moon. So just waiting for people to... What is the answer there when you multiply? What answer are you getting? What answer? 100.2 newtons. So that is the answer that you are getting. So 100.2, 100.2. Have you seen? So the answer that we are getting in this case is just what? 100.2. So this is the answer that we are getting. So this is the what? This is the weight of some 100 kg mass when it goes to the what? To the moon. This will be the weight. So this is what you need to know. This is what you need to understand. These are some of the things that should be known. You need to make sure that you know this. You need to make sure that you understand this. So these are some of the basics that should be known. These are some of the things that you need to know. So let us now move forward and look at another last part. Then we end the class. So we look at one more last thing. Then we end this. So there is something that is called stability. So I think we've heard of this word, that for objects to be stable, there are certain things that must be followed, sir. But is it not just... let me see this comment. Let me see this comment. To just use 1.6. You just finish it. 1.67. Because we usually put answers to 2 decimal places or 3 significant figures. So you just say 1.67, 1.67, 1.67. Just use 1.67. It is fine. But if you want, you can just write the way it is. You say 10 times 1 over 6. You also include it. So you can write it that way. So now we are talking about stability here. I want us to look at this interesting part. So under stability, what you need to know and understand is that this is just the ability. So we are just talking about the ability of an object. Ability of an object to regain. So the ability of an object to regain its original. To regain its original position. So to regain its original position when it has been slightly moved. So slightly moved or slightly displaced. This is what stability is. So this is what you need to know and understand. So whenever we are talking about stability, you discover that we just get to talk about 2 important things, which is the center of gravity and the what? And the base. So it is called the area base. So we just talk about these 2 things. For a body to maintain its stability. For example, you can have something like this. Have you seen? You can have something that is like this. So this is, let's say this is the earth, like that. This is the ground. Then you also have something that is like this. Like this. So now, which one is stable? So we are just talking about stability here. Which one is stable in that case? Which one is stable? You are going to say that the center of gravity in here is this one. the center of gravity there, it is that one. There, have you seen? So the center of gravity in there, it is that one. And the center of gravity here is somewhere here. That's where we have the center of gravity, somewhere there. But in that other one, the center of gravity is there. So which one seems to be more stable here? You are going to tell me that this one is more stable because the center of gravity is lower than that one. So it means that if the center of gravity gets to be lower, this is how you get to increase the stability of an object. One, you make a lower center of gravity, not a higher one, lower center of gravity. So these are questions that get to come in an exam. Make sure that you understand this, you get this point that I'm explaining here. So this one, you know that the center of gravity, that is a point where all forces seems to be acting on. So all the forces of that particular things seem to be acting on. So that is the what? That is the center of gravity. So all the forces are acting on this point. And all the forces are acting on that point. So if this is A and this is B, then they ask you which one is more stable. The one that is more stable is this one because it has a lower what? Center of gravity. Its center of gravity is down, meaning that the object is able to balance, or it is more stable like that. Have you seen? This is what you need to know. But in terms of area base, you discover that you can have something like this. You're going to have something that is like this, here like this, something that is like that. You are given something like that is like this. You are also given something that is like that. Like this. They give you these two things. They say this is A, this is B. So now they ask you a question to say which one is more stable here. Which one is more stable? You are even able to tell that the one is more stable is A because it is having a large surface area. So we are talking about what? Area base. So this one is more stable because it has a large surface area compared to that one. So that is why a bus is advisable to be putting those luggage down there, not on top, because when they are put on top, you discover that the center of gravity is affected, hence the stability is also dealt with. That's why once a bus involved with those buses that used to carry things on top, down there is nothing. So once it meets an amp or maybe a certain hill, you discover that it can even go that way, upside down like that. So that's why things are advisable to they put those luggage down there so that they are able to see what is happening. They are able to see that this thing is more stable now. So that is what gets to happen. So make sure that you understand this. So this one is more stable compared to this one because there is a larger, wider base here compared to this one there. So you just understand that the center, or whenever we are talking about the stability of an object, is dependent on these two things: center of gravity and the area base, or surface area base. So this is what you need to know. These are some of the things that you need to understand and take note of. So this is where we are going to end from. This is where we are going to end from. This is our lesson for today. Even as we end this, let's make sure that we share this video to 1 or 3 people or in a group. So let's make sure that we keep sharing. Let's make sure that we share this video. Let's share this for those of you that wants to start lessons with me. Those of you that wants to join my online lessons, you get to WhatsApp me on this number. This is my WhatsApp number. This is my WhatsApp number. You WhatsApp me on this number. This is my WhatsApp number. Per subject. So whenever you want to pay for science, when you want to pay for science, you just need to pay 100 kwacha. This is for both chemistry and physics. Mathematics is what? 100 kwacha. Mathematics is 100 kwacha, like this. So these are the fees you deposit in this account number. That is my mobile number. You deposit in that. If you are using MTN, there is this number. They all bring my name. So you confirm the name like this. These are my mobile numbers that I get to use. So this is what you need to know. This is what you need to understand. Okay, so before we even conclude, I prepared a question here. Let us see how we can answer this particular question. So these are the numbers you need to call for payments, and if you want to be added to the group. So you only text me on the Airtel one. You text me on the Airtel. I prepared a question here. So let's see how we are going to answer it. I want us to answer this particular question together. So it is saying the weight. So the weight of an object. The weight of an object is. So this question is your question. This is not my question. I want you to answer it. The first question is saying, what is its mass on the moon? On the what? On the moon. This is the first question. Then 2, they are saying that what is its weight? What is its weight and mass on the what? What is its mass and weight on the moon and Earth? This is your question. This is your question. This one is your question. So how are we going to answer this? This is your question. So I'm just waiting for comments. I'm just waiting for comments. So let's see how we are going to answer this. What is its mass on the moon? What is the mass of that on the moon? What is the mass? What is the mass? So let us answer this together. What is the mass? What is the mass? What is the mass? So what you are going to do for you to answer this particular question, you know that the formula when you say weight is equal to mass times gravity. So they are talking about the moon. So you know the gravity on the moon. Weight you are given, that is 300, which is equal to, you want to find the mass. So you want to find the mass, you multiply by gravity 1.67. Meaning that for you to find the mass, this one is just the same as 300 is equal to 1.67 m, which is the mass. Divide both sides by 1.67. You divide both sides by 1.67. So this and that will be cancelled. You remain with the mass. What is the mass there? When we divide, what answer are we getting? So I'm just helping you answer that. So what is the answer there when you divide? What answer are we getting when we divide? What is the answer there? What answer are you getting? What is the answer there when you divide? So waiting for you to comment. Waiting for you to comment. Well, this is your question. So what answer are you getting? 300 when you divide by 1.67. What answer are you getting? What answer are you going to get? What is your answer? What is your answer? So this is 180, right? 180. So 180. Someone said 180. So we've got 180 kg. So that is you said this is from Lizzie saying 179.64. So I've just converted it to the nearest whole number, which is 180. So we've found 180, right? We've calculated 180, right? So 180, that is the mass. That is the mass. So that is the mass that you need to know when it goes to the what? To the moon. Then question B is saying, what is its weight and mass on the moon and Earth? you know that the weight. So starting with the weight, we know that the first question here, we've answered the first question that it is what? 180 kg. This is what we've discussed. Then going to this other question, going to this other one, we are able to find that we want to find the what? We want to find the weight and the mass when it is, so weight and mass. Want to find the weight and the mass when it is where? When it is on these two places, when it is on the moon and earth. So you know that the mass is the same, 180 kg. Even there it is 180 kgs. So the mass is the same everywhere. So can somebody tell me what is the mass? What is the weight on this one? What is the weight on the moon? And what is the weight on the earth? Can somebody tell me those two answers? Okay, gravity. So I like these calculations. Let me see. 180. Okay, this is so good from me over. So that is 180. Yeah, I think. So we want now to find, I think you've seen this particular question. So we want to find the weight on the moon and on the earth. So this is what I want us to do. So what is the answer there? What is the answer? What is the answer there? What is the weight on the moon? And what is the weight on the earth? Waiting for you people to comment. So just comment. On the moon is like that. On the earth is like that. So mass is the same. We know that mass is the same. Mass is the same. So let us be quick. Let's be quick. We are just multiplying. If you want to find for the moon, so you just say moon there, what you are given, you just say, you know that weight is equal to mass times gravity. So mass, you know, 180 times gravity, 1.67. What answer are you getting? What is your answer there? You just do that. I don't know why people are even wasting time here. You do this. When you go to the earth, you know that you are just doing, what is mass? Mass times gravity. So earth is 180 times 10. So this one is even simple. 180 times 10. This is what? 1,800. So that is the weight on earth. You say Newton. What about that other one? These are simple questions. That is what? 10301. Have you seen? So that is the answer that you've calculated. So we just say this is what? 300.6 newtons, like that. This is how we've calculated. So this is what we are supposed to do. On the earth, like that, okay. Seems this is understood. People have gotten the point. So this is what you need to know. This is what you need to understand. So these are some of the things that you need to know. These are some of the things that you need to understand. As simple as this. I believe we can't fail these things in an exam. We can't fail. So these are questions that we need to take advantage of. We are going to end here. This is where we are going to end from. Those of you that want tuitions, I've given you my number. That the Airtel one, that's my WhatsApp number. You pay in that one, or if you want to text me, you use that same one. So we end here. Thank you so much for joining me. Let's make sure that we share. Let's share. People don't share. I don't know why. I don't know what we are afraid of. People don't share. I don't know why people don't share. So let's keep on sharing, and let's make sure that if you want tuitions, you join so that we can see what I can do. I try to help you get good grades. So I get to teach on a daily basis, Monday to Friday. Mathematics, we start at 20 hours. Science starts at 21 hours. This is how I get to do them. So let's make sure that we share this video. Let's share this video. Let's share this video. Let's share this video. Let's keep sharing. Let's keep sharing. Let's keep sharing so that we get to have a larger audience. So let's keep on sharing. Let's keep on sharing. Let's share. Let's share. Let's share. Let's make sure that we share. We share. Let's share. Let's share. Let's share. I can see Maria saying connected. Okay, it's good that people are connected. So just waiting for you to share even as I get to end this broadcast. Right now, I can see the number of people that are watching. So if these people can share each in 4 groups. So if these people connected, if you can just share in just 4 groups. I don't know why people don't like sharing. So if the people watching can share in just 4 groups, you won't lose anything. Nothing about you will be affected or changed. 4 groups. Click on 4 groups. You share in 4 groups. Thank you so much. We end here. We continue tomorrow. This is School at 5. School at 5 is here to help you get a distinction. Don't forget, this is your tutor, Addison J. Zuru. Thank you so much.